All right, and here we're going to be approximating 0, so we're not actually going to find the exact spot, the exact zeros, just approximating it. All right, and we can do that with a table. So determine between which consecutive integers the real zeros of each function are located on the given interval. Alright, so we have the function f of x equals x squared minus x minus 3/4, and our interval is from -2 to 2. How do you know this is an interval? Because we had those brackets and because they told us. Alright, so from -2 to 2. So -2 is the smallest, and then go up from there. So -2, -1, 0, 1, and 2. So we had to make an xy table and then use those intervals to find the x values. And now we're just going to plug in those numbers. Okay, so we're going to plug in -2 for x here. So we have, I'm going to put this one in parentheses because it's a negative, so 2 negative, oops, there we go, close parentheses, and then square it. Good. You get 4 minus -2 minus, okay, good. And here I'm going to put 3/4. I'm hoping this is 3 divided by 4. Yeah, that's it. Good. So 5.25. Alright, and I didn't realize that the camera wasn't really on the calculator, so let's just do one more and then I'll stop for the rest. So now our x is -1, so parentheses, sorry, let me clear this first. Parentheses, 1 negative, close parentheses, squared, then minus 1 negative minus 3 divided by 4, and equals, ta-da, 1.25. Okay, so we'll do the rest. Alright, so here's what we got. When we plug those in, we get 5.24, 1.25, -0.75, -0.75, oh, same, and then 1.25. Alright, how can you tell where the zeros are? You want to look where the signs change. So where do the signs change? So I'm going to put underneath. We have a positive here, positive. Ooh, it's a negative. -0.7. So here's 1. And then you have a negative again. And then a positive. Hey, sign change. There we go. So the intervals are between. The zeros are in between -1 and 0. And 1 and in between, I'll put between again, between 1 and 2. There you go. So the 0 is somewhere there in between those two. Let's do the next one. So same thing, function, and then we have our interval from -2 to 2 again. So we make our xy table, -2, -1, 0, 1, and 2. Alright, let's plug it in. So let's just do this in our head. So negative 2 to the third power is going to be negative 8 because it is cubed. So negative 8 plus, and then 2 times negative 2 is going to give us negative 4. So negative 8 minus 4 is going to be negative 12 plus 5. Negative 12 plus 5 is negative 7. And then you have negative 1. So negative 1 cubed, so it's going to be negative 1. Then 2 times negative 1 is negative 2. So negative 1 minus 2 is negative 3 plus 5 is 2. Positive 2. And 0. Ooh, I like those zeros. 0, 0, so it's just 5. And 1. 1 plus 2 times 1 is 2, so 1 plus 2 is 3, plus 5 is 8. Ooh, looks like it's going up. And 2, so 8. Then plus 4 is 12. Plus 5 is 17. Ooh, that's going up quickly. And look at that. So where do the signs change? We have a negative, positive, 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 positive. So where do the signs change? At x equals negative 2 and negative 1. So between the zeros, there's only one, is between negative 2 and negative 1. So this one only has 1, 0, one x-intercept. Oops, wrong one. So let me show you what the graph looks like. I'll show you for the first one first. All right, so from, and remember we're just looking at from negative 2 to 2. And there we go. So it's in between negative 1, negative 1 and 0, like we said, and between 1 and 2. Ta-da! Yeah. So that's that one. Let's look at the second graph. Ooh! Now this is a pretty big graph. Luckily, they gave us the interval from negative 2 to 2. So from negative 2, and then it only has an x-intercept once right there, right? So what number is that in between? It's in between negative 2 and negative 1. So just like what we said, And that's that.